This is the assignment for April 29th, College Algebra, Unit 4, Section 4. The rest of it, problems 3, 4, 6, 7, 8, and 9. I've done the even ones here. I've done 3 of the 6. Number 3 is written there, 6x cubed plus x squared minus 19x plus 6. That's a cubic polynomial. It'd have a shape much like what we get on number 4. Okay, number 4, 6x cubed minus 17x squared minus 31x plus 12. We need to find the x-intercepts. That is done with the method we learned in this unit here. There are 2 sign changes in the original problem, positive 6 to negative 17. And then from negative 17 it stays negative, and then it turns positive. 2 sign changes, so 2 positive roots, 1 negative. Then we put the last number 12 over the first number 6 to give us the possibilities, and they're written out there. 12, 6, 4, 3, 2, 1 for 12, and then 1, 2, 3, 6 for 6. I saved a little time there. The first root is 1/3. I used it, synthetic division, and that left me 6, negative 15, and negative 36, which I showed there. I took a 3 out of that and factored what is left, or what is left, use a quadratic formula. But negative 3/2 and 4 and that 1/3 are your x-intercepts. Y-intercept is found by putting 0 in for your x's, and it comes out to this 12. The domain, there's no denominators with x's, there's no radicals, so it's all real numbers. Okay, the range I forgot to write is also all real numbers. Then I used a calculator to find the table with assorted values there, or by hand if you don't have a calculator, but you need to have some values. Then I used my y-intercept you see there, and then I have negative 3/2, which is negative 1.5, and 4, and then 1/2 are my x-intercepts. I marked them, and then found some other values, and remember this is the general shape of a cubic polynomial, and the range was also all real numbers. Then we go to the rational expression f of x equals 1 over x plus 3. First, find your domain. The domain, the only thing that can be left out of it is that denominator, x plus 3. X cannot be negative 3, so our domain is everything but negative 3. That gives us the very important thing, the vertical asymptote. X equals negative 3. Our graph cannot cross that x, that line there. X equals negative 3. It will, as you see eventually, it will go up towards infinity or down towards negative infinity next to a vertical asymptote. Then we find the range. The range is found by looking at your equation, taking the x term in the numerator. There was not one, so 0x over the x term in the denominator, 1x, and simplifying that. 0 over 1 is 0, so your range is all real numbers but 0. That gives us our horizontal asymptote, which is this line right here. And our graph does not cross it. Then I look for an x-intercept by setting the numerator equal to 0. Well, there's no way 1 can equal 0, so there's no x-intercept. The y-intercept, as always, put 0 in for the x, we get 1/3, so 0, 1/3. So now you don't need to know a lot of points after you've got the vertical asymptote drawn and horizontal asymptote drawn. You know that it's divided up into kind of 4 different areas, an area here, an area here, an area here, and an area here. once you start getting points like over to the right of the vertical asymptote, I had the point -2, 1, and the point -1, 1/2, and 0, 1/3. So that tells me my whole graph is in that area. As it goes this way, it goes along the horizontal asymptote, but doesn't touch it. As it goes this way, it goes up along the vertical asymptote to infinity. Then I put points into this side, and that was -4, was -1, -5 was -1/2, showing me that it was in this area. And as it's in this area, if it's coming closer to the vertical asymptote, it goes towards -infinity. As it goes to the left, it goes along the horizontal line. And that's how you graph that rational expression. Number 7 and 9 are written here, what the equations are. But number 8 is the one I did. Same way, f of x over 1 equals 1 over 2 minus x. The domain comes from the denominator, all real numbers, but 2. That tells me my vertical asymptote, x equals 2. That's the first thing I draw, a dotted line, a vertical dotted line, that asymptote. Our graph cannot cross it. Then I find our range by putting the x term in the numerator, which there is not one. So 0x over the x term in the denominator, -1x. 0 over -1 is 0. So the range is all real numbers but 0. The horizontal asymptote then is 0, right along the x-axis then. Then I find my x-intercept again by setting my numerator again equal to 0. In this case, again, just like number 6, 1 cannot equal 0, so there's no x-intercept. It can't cross. Anyway, it can't cross that horizontal asymptote. The y-intercept, put 0 in for your x, you get 1/2. So 0, 1/2 is one of my points there, and I know my graph is going to be in that area. And then I took my table and found another point, 1, which gave me 1 right in there. And remember, my graph, 2 points there. This side's going towards that vertical asymptote, so it will go to infinity. This side's going towards this along here, so it'll keep going along it, not cross it. Then I put in 3 and 4 to see what it was doing over here, and of course it's down here, not up here, it's down here. And so that tells me this way it's going to go along here, and the other way it's going to go towards -infinity.